Good morning, Chem 20s. Our lesson today is going to be on stoichiometry. This will be a series of lessons. We're going to start today on something called gravimetric stoichiometry. Stoichiometry is a method of predicting and analyzing the quantities of materials consumed and produced in a chemical reaction. It is a section of chemistry that involves using relationships between the reactants and the products in a chemical reaction to determine the desired quantitative data. This is key. Stoichiometry is a process of determining numerical data. So we're going to be doing math when doing stoichiometry. In order to understand stoich, we are going to have an understanding of how balanced reactions work. So if we take a look at a chemical equation and we think of it like a recipe, we're going to include the ingredients like we would in a recipe, much the same as we would include elements or molecules or ions in a chemical reaction. We have reactants on the left, we have products on the right. So if we take a look at this goofy little example, we have 2 slices of bread, and we're going to add to it 1 slice of cheese. In this scenario, that means we will make 1 cheese sandwich. Now, this balancing numbers, these are going to be important. So again, we have a 2 for slices of bread. If we don't write it down, of course, we have a 1 here for slices of cheese. And again, we'll make 1 sandwich. Well, this will relate to something we looked at in grade 9 called the law of conservation of mass. I'll remind you that the law of conservation of mass states matter is neither created nor destroyed in a chemical reaction. It is only changed from one form to another. So we are taking pieces of bread and a slice of cheese, and we are building it into an actual sandwich. We still, when we are finished, still have our 2 slices of bread. We still have our 1 slice of cheese. It's just that it shows up in a different form. In our case, a sandwich. Now, in stoichiometry, we are going to look at 3 cases. Today, we're going to focus on gravimetric stoich. This is stoichiometry that pertains to mass measurements. Remember, this is a process. We're going to do calculations in order to determine some sort of mass measurement. No matter which type of stoichiometry we are doing, there is always 4 assumptions that we have to make. In stoichiometry, all reactions are spontaneous, fast, quantitative, and lastly, stoichiometric. When we say a reaction is spontaneous, that means that when I mix 2 chemicals or I have a compound and it will break down, these substances, there will be a reaction when these substances are mixed. Secondly, when I say reactions are fast, this means that the reaction will occur in a reasonable amount of time. We will not have to wait hours or days or even a year for bigger reactions like rusting to occur. Number 3, reactions are quantitative. That means the reaction is more than 99% complete, meaning my reaction will go to completion. I will see my reaction stop reacting. And last but not least, reactions are stoichiometric. That means that I am going to balance my chemical reactions in whole numbers so that there will be a ratio of chemical amounts of reactants to products, and they will be in the lowest whole number coefficients. Now, when I said stoichiometry is a process, that means that it doesn't matter which of the 3 types of stoich we are going to do, gravimetric, solution, or gas stoichiometry, we're going to always follow these 5 steps. You'll notice that these steps don't really include formulas. The formulas are secondary. You already know them from previous chemistry studies. What you're going to notice is, as we go through the steps, step 3 would say, convert known values into moles. Now, it doesn't tell you how you're going to do that. We have many formulas we've learned already that includes the mole variable. So in step 3, it's not about use this formula. It's about, given the information we provide with you, calculate the number of moles. Same with for step 5. Given the information you now have, answer the problem. In some examples, that might be calculate the mass. In other examples, that might be calculate the concentration or the volume or the pressure or the temperature. Each question will be different based on the variables or the information provided in the question. This is the general 5 steps we're going to do. Here is what I would do. Copy down these 5 steps. And we're going to keep referring back to these 5, especially in the beginning as we practice doing stoichiometry for the first time. The example we're going to do first is, what mass of water vapor is produced when 33 grams of oxygen gas is reacted completely with hydrogen gas? Here is what I would do. I would copy the question, and then I'm going to go through these steps. You'll notice I pasted the 5 steps up here on the top right-hand corner. I'm going to go through the steps one at a time. As I complete a step, I will put a check mark so you can see what each step looks like. In all honesty, all the steps are fairly straightforward. Step 4 takes a little bit of just paying attention, but other than that, we are honestly doing nothing new compared to what we have done in previous chemistry lessons. So let's take a look at example number 1. Step 1 says write the balanced chemical equation. So if I go to do this, what mass of water vapor is produced? So I am going to be making water vapor. I have to write it as H2O. And again, since it says vapor, I know we are talking about a gas. Now, we are going to mix here hydrogen gas and oxygen gas. I want to remind us that it says balanced chemical reaction. So let's make sure this is balanced. 2 hydrogens, 2 hydrogens. 1 oxygen, 2 oxygens. Therefore, I have to put a 2 here because we have to use whole numbers. So 2 oxygens, 2 oxygens, 4 hydrogens on the right. I'm going to need a 2 here, so I have 4 hydrogens on the left. Step 1 says write the balanced chemical equation. We did that step. Step 2, identify the knowns and the unknowns. This is probably the most important step because this is the organizational piece. If you are naturally a messy person, this would be the step that you have to be the most cautious on. So in the question, it says, what mass of water vapor? So underneath where we have water vapor, we are going to calculate mass. That is my goal. It is important that we put down what are we trying to solve for in this question. The question also tells me we have 33 grams of oxygen. So underneath oxygen, we're going to write the mass is 33.0 grams. Now, this is very, very important. When we're doing this, I want you to think of this, since I have 2 reactants and a product, as 3 different categories. If I had any information about hydrogen, I would group it under hydrogen. If I have any info under oxygen, I would group it under oxygen. And same goes for any information about water vapor, I would group it under water vapor. Now, because we're dealing with masses, we know that we have not done any calculations where when we have mass, we don't need molar mass, so we're going to have to calculate it. So again, we have molar mass. So oxygen is 16. I have 2 oxygens, so this is going to be 32.00 grams per mole. For water, this is about the only molar mass we have memorized, 18.02 grams per mole. Now, we have written down all the information we know in the question. Step 3 says, convert our known values into moles. Now, in order for us to do this, I want you to look at the 2 categories, the water category and the oxygen category. Which of these categories do I know enough information that I can find moles? Well, I think we agree that we have a formula where if I have mass and molar mass, I can calculate moles. So step number 1 for math, I am going to find moles of O2. Now, I am a firm believer of using a subscript to organize our work. This way, we know when we're looking at our work that we are finding the moles of oxygen, not the moles of hydrogen, not the moles of water vapor. So, to find the moles of oxygen, we know the formula is mass over molar mass. So, I'm going to take my mass that I've organized already, 33.0 grams. We're going to put it over top of 32.00 grams per mole. And we're going to get a number of, so 33.0 divided by 32.00. Answer, I have 3 sig digs, so my answer will be 1.03 moles. So I have calculated moles. Step number 4, find the moles of the unknown. So now that I have found the moles of the substance I knew everything about, I'm now going to find the moles of my mystery substance, meaning the substance with the question mark, the substance where I'm going to eventually find out an unknown piece of information. So to find the moles of H2O, again, like when we did concentration statements, when we do a mole ratio, and that's what this step is called, a mole ratio step, we write down the value we know for moles. So we just calculated the moles of O2, so I'm going to write it down, 1.03 moles. So I know the moles of O2, I copy down that number. From here, I'm going to play a little game of leapfrog. I'm going to multiply the moles of the unknown, the question mark moles. So that's going to be 2 moles. I'm then going to play a little game of leapfrog back. I'm going to divide by the coefficient of my known. And since I don't have one written here, we know it's 1 mole. So write down the moles that you just calculated of the known value. Play a little game of leapfrog. Multiply by the coefficient of your unknown, divide by the coefficient of your known. So I'm going to take the full calculator number times by 2, divide by 1. I'm still only allowed 3 significant digits, so my answer is 2.06 moles. Again, keep the full calculator number in your calculator. My last step is, now that I've found the moles of water and I know the molar mass of water, I can calculate the mass of water. So at this stage, because we've been doing these formulas for so long, I am going to allow you to not have to write the original formula. If you need to write the original formula off on the side of your paper and then write down how to move it around to solve for mass, go ahead and do that. I am just going to go straight to the moved around formula. You still need a formula. What I'm not making you do is write down the original memorized one. So to solve for mass, molar mass is going to move up, so it's going to be moles times molar mass. So my moles is 2.06 moles. My molar mass is 18.02 grams per mole. So I'm going to take my full calculator number, go times 18.02. I'm still only allowed 3 significant digits because that's what the question tells me. So my answer is going to be 37.2 grams. Again, I've done my mole ratio step, and now I've answered the problem in the appropriate units. So when I go to mark this, and I'm going to change pen colors here for a second, because I really want you to see this. Okay. A question like this in stoichiometry would be out of 5 marks. You get your first mark for the balanced chemical reaction. So it's been balanced correctly, you've written it correctly, you get 1 mark. Now, the thing that is not counted in this 1 mark are your states. If you, for instance, did not read the question carefully enough and you wrote H2O liquid, I would not dock you for this right now. I would underline it and let you know that you got it wrong, but your balanced chemical reaction is for the correct reactants, products, and balancing. It has nothing to do with states at this time. Your second mark is for calculating the number of moles of the known value. So you've got the formula, you've got the substitution with units, you have an answer. At this time, I am not marking significant digits or your units. However, if you do not show me any of your work, your formula, or your calculation, I will not give you the second mark. Your third mark is for your mole ratio. You've taken your known value of moles, you've multiplied it by your unknown coefficient over your known coefficient, and you've gotten me a correct number. Again, I would be ignoring your value as well as your states at this time. Your fourth mark is going to be for answering the problem. In our case, we had to find a mass. Therefore, we have a formula, we have a substitution, we have an answer. If you do not show me the process, the formula, or the substitution, I will not give you the mark. Then there is a final fifth mark. This fifth mark is for something we call conventions. Conventions are states, conventions are significant digits, and conventions are units. So if in the balanced chemical reaction you get one state wrong, I will ignore one state. However, the moment you get two states or more states wrong, or you skip them, you will automatically lose your fifth mark. We do not give half marks in stoichiometry. Anywhere on the page, if you forget to include a unit, whether in substitution, whether in answers, or whether in planning, you will automatically lose the full fifth mark. And lastly, in any of your mathematical process steps, whether it's finding the moles of the known value, finding the moles of the unknown value, or answering the problem, at any of these three stages, if you get the significant digits wrong, you will lose the fifth mark. The fifth mark is the important one. That's more or less the are you paying attention to details mark. Here's what I would do. Please copy example number 2. You will see it's very similar to example number 1. We're just going to solve for something different. And then pause the video. I would like you to write the balanced chemical equation. I would like you to organize and determine your known and unknown values. And then I would like you to try to do steps 3, 4, and 5, the math steps, following the process. If you get stuck, please unpause the video to check my work as I go through this question. So the first thing I'm going to do is go back to my lime green pen. So if 250 grams of water vapor is produced, so we're going to do the same question over again for the equation. So H2 gas plus O2 gas goes to water vapor. So two H's, one O, two O's. So I'm going to need a 2 here. Now I have 4 hydrogens on the right. I'm going to need 4 hydrogens on the left. It tells me in the question this time, I have a mass of water of 250.0 grams. I'm trying to find what mass of hydrogen would I need in order to make 250 grams of water. Now, again, this is gravimetric stoich because this is pertaining to mass calculations. Therefore, we know when we have masses, we need molar masses. Since it's H2, we're going to have 2 hydrogens, so my molar mass is going to be 2.02 grams per mole. Again, for water, we have 1.01 plus 1.01 plus 16, so the molar mass of water is 18.02 grams per mole. So step number 1, we wrote the balanced chemical reaction. Step 2, we've identified our knowns and unknowns. Step 3, where do I have enough information to calculate moles? Well, for water vapor, I have mass and molar mass, so that's going to be where I start. I'm going to find the moles of H2O. Mass over molar mass. 250.0 grams divided by 18.02 grams per mole. So 250 divided by 18.02. I go back, I'm allowed 4 sig digs in the question, so my answer is going to be 13.87 moles. Now that I know the moles of my known values, I am going to do the mole ratio. So to find the moles of H2, right, to find the moles of the unknown, take the moles you already know. So copy the number you just copied down, 13.87 moles. Remember, that's the moles of water vapor. So we're going to play a little game of leapfrog. We're going to multiply by 2 moles of my unknown, and then we're going to leap back and divide by 2 moles of my known value. So I'm going to take my full calculator number, multiply by 2, divide by 2. I think we all realize our number is going to stay exactly the same because it's a 2-to-2 ratio, so it doesn't change anything. And last but not least, our job is to find what is the mass of hydrogen. Well, now that we know the molar mass and you just calculated for me the moles, we can move the formula around. Mass equals moles times molar mass. Take 13.87 moles, multiply by 2.02 grams per mole. And my answer in 4 sig digs is going to be 28.02 grams. Again, if I was assigning marks, 1 mark is for the balanced chemical reaction, 1 mark is for calculating moles, 3rd mark is for doing the mole ratio to calculate moles of my unknown, 4th mark is for answering the problem, so in our case, calculating mass, and my 5th mark is for having 4 sig digs, 4 sig digs, 4 sig digs, units on every value everywhere, including the organizational values. And my 5th mark is also for having 3 correct states on the balanced chemical reaction. On this question, we will have earned 5 out of 5. Okay, last question. I would like you to do this one completely for yourself before unpausing the video. Pause now, copy the question, and get as far as you can, please. So the combustion of methane. So we are going to burn methane. So methane is CH4 gas. It's one of our memorized molecular compounds. We're going to add to it oxygen gas. Remembering oxygen is diatomic, and anytime we burn something, we need oxygen for that to occur. We know that anytime we burn carbon, we're going to make carbon dioxide gas. And anytime we burn hydrogen, we're going to make water vapor, so H2O gas. We need to balance the chemical reaction, so 1 carbon on the left, 1 carbon on the right, 4 hydrogens on the left. I'm going to need a 2 here, so we have 4 hydrogens on the right. 2 oxygens plus 2 oxygens is 4 oxygens on the right, which means I need to put a 2 here, so I have 4 oxygens on the left. 1 mark for the balanced chemical reaction. Second thing we're going to do is organize our work by putting down what we know and what we're trying to find underneath our substances. So it tells us in the question we have a mass of methane of 4.20 grams. We are trying to find out what mass of water vapor will be produced if we burn 4.20 grams of methane. Now again, because we're doing masses, because this is gravimetric stoichiometry, we are going to need to calculate molar mass. So water again is 18.02. And it just so happens we're doing a lot of questions with water in it. That's not a big deal. We could have solved for anything. The question could have said, what is the mass of CO2? We could calculate that as well. Okay, for methane, we're going to add 12.01 plus 1.014 times. So my molar mass of methane is going to be 16.05 grams per mole. I hope you're seeing how important it is to organize your work into columns so that you don't pull something goofy from the wrong spot. So, step number 2, we've identified our knowns and unknowns. Step number 3, calculate the moles of our knowns. So, I know enough information here for methane to find the moles of methane. So, mass over molar mass. We're going to take 4.20 grams, divide by 16.05 grams per mole. So 4.20 divided by 16.05. And we are allowed 3 sig digs in the question, so 0.262 moles of methane. Well, our fourth step is to do the mole ratio. So we are trying to find now the moles of water. So write down the moles that you already know. So that's the moles we just calculated. We're going to multiply by the moles of our unknown where our question mark is. So this is going to be times 2 moles. And then we're going to leapfrog back and we're going to divide by our known moles, which is a 1 right here. So times by 2. Still in 3 significant digits, 0.523 moles. Last but not least, we're going to answer the problem. Since the problem wants us to find the mass of water, move the formula around so it's moles times molar mass. We just calculated the moles of H2O to be 0.523. Again, we're going to use our full calculator number. We're going to multiply the molar mass of 18.02 grams per mole. And we're going to put our answer in 3 sig digs. 9.43 grams. Again, mole ratio step, answered the problem. You will see, Stoich is a process. We don't tell you which formulas we're going to need. Instead, we say, hey, in step 3, calculate the moles of what you know. In step 5, answer the problem. If you want mass, solve for mass. Move the formula around accordingly. Again, 5 marks, balanced chemical reaction, moles of known, moles of unknown using a mole ratio, calculate our answer to the problem. 5th mark, all the states are right, sig digs are all correct in my 3 math steps, as well as I have units everywhere. I'd like to point out when doing molar mass, notice we're doing the molar mass of H2O, not 2H2O. We don't have to worry about the balancing numbers because we have a step built into the stoichiometry process for that. That is why we have the mole ratio step. Therefore, when doing molar mass, just do the molar mass of the compound, not the quantity of the compound. So H2O, the molar mass is 18.02. We do not care that it's 2H2O.